we were just discussing about the interconversion of the three states of matter. When different states are interconvertible, this is called as interconversion between three states of matter. It simply refers to how liquid could be converted into the gases, how solid could be converted into the gases, and all that. In a general perspective, you will be asked to define interconversion of the three states of matter. The first point is that if you heat a solid, the energy provided by the heat source makes the particle to vibrate faster and faster and faster. Simply, that vibration is directly proportional to the heat. The more heat you will be providing, the more faster they will be vibrating. Eventually, they vibrate so fast that the forces of attraction between the particles are no longer stronger enough to hold them together. Simply now those particles that you can see, they were too strong to hold the particles. They were tightly holding each other, not letting them out. Now, what they're saying is that forces of attraction between the particles are no longer stronger enough to hold them. They are going to like get rid of the defense system or the power with which they were holding each other. So gradually, these particles are now unable to hold them together. The reason is that so they will break up those attractive forces and the particles will leave each other. So that makes solid particles to melt up and it will be converting themselves into the liquid. So that temperature, that fixed point at which this melting is going to take in place is called as melting point, and the solid will be melting up to convert them into the liquid state. Now, for the daily examples, you could say that you have solid and an ice cube. So it was an ice cube because you were providing it with that temperature in which they were not having any, they were unable to receive any heat so that their bond could be broken off. Now, gradually, when you put them out of the refrigerator, the freezer, you are going to put them in that higher temperature. So, increase in temperature force those particles to vibrate strongly, and when they vibrate strongly, it makes them to break the bond. It is the point when first particle from the solid convert into the liquid was called as melting point. Every liquid or every solid has its own specific melting point. It will melt only at that specific temperature if it is pure. If it would to be impure substance or containing impurities into it, it won't be allowed to melt up at that temperature. It will show some sort of variation in that particular point. Now, the particles in a liquid have more kinetic energy than the particles in the solid, so that this energy has to be supplied, would be converting the solid into a liquid state. Here is the solid. Now the solid melts up, it receives just heat. Upon receiving the heat, it will be converting into the liquid. So simply, whenever we are providing with the heat with a high temperature, we are going to put this energy into them. When you put on that energy into that solid, it will be causing a melting of this solid into the liquid, and it would increase the spaces between the particles. Now, when you take that energy out and you cause them to decrease the space between the particles, they would cause it to convert this energy into the solid form. So this is called as freezing point. Now we are clear with the 2 points. The first point was that melting point. Whenever you you are going to provide excessive heat to a solid so that it could broke up its attraction or the bonds and it convert that solid into liquid, this was called as melting point. When you release that energy out of that liquid and convert it into the solid, this point is called as freezing point. Is there any confusion? Okay. Now, the next point is going to be okay. The next point is going to be how substances are going to move ahead to the this phase which is called as freezing point. If a liquid is cooled again, and the liquid particles will move around more and more slowly. Eventually they are moving so slowly that the forces of attraction between them will hold them in a fixed position. See, now you can make a difference between them. The first point was that we force them to move. We just put that energy into them so that they could broke up their bond. They could like increase the spaces between them so that we could shift themselves from the solid to the liquid. Now when we just decrease the temperature, when we increase the spaces between the particles, what we did, we just took the energy out, and now if we force those particles to come closer, to decrease the spaces between them, to decrease the energy between them, that was the point when we make it to convert itself from liquid to solid form. So that particular point, when we are reversing that entire activity, this was called as the freezing point. Now, although they are called different things depending upon why you are going, or whatever you are going to do, the temperature of the melting point and that of the freezing point, they are exactly the same. How and why is it exactly the same? Because it is the fixed point. It is that particular point when there is a transition between solid to liquid and liquid to solid takes place. So that the melting point and the freezing point, it is exactly the same. See, it is the particular point when you are forcing the particles to come closer. It is that particular point when you are forcing the particles to increase their distance, the distance spaces between them. So you should be clear that the melting point and freezing point of a particular substance are exactly the same. Now, there are the two different ways things can happen, that is called as boiling and evaporation. Okay, now what they are. Simply, boiling occurs when a liquid is heated strongly, when you are going to put the heat inside it, when you are providing it with the actual heat, it is going to bubble up. So, the particles are allowed to move even faster and faster so that they could overcome all the attraction between them. The stronger the forces of attraction between the particles are, the higher the boiling temperature would be. So the more you increase the heat, the more strongly you turn the stove on, the more pressure it would put upon to the particles and the more fastly they will be vibrating. Now, this is because more energy is required to overcome these forces of attraction. Whenever you overcome the particles overcome these forces of attraction, the more easily they will be boiled down. Now, if a gas is cooled down, the temperature eventually moves slowly. Now you are decreasing the temperature. The gas is allowed to stay calm. It is allowed to stay cool. Now eventually the particles will move slowly enough. They will move slowly enough that the forces of attraction between them start to create enough. Now we are making the shift from gases to liquid. See, I'm gonna make it simple for you. First thing I taught you was about, it was about what was it about? It was about freezing point. Like melting point. Whenever we put the temperature to the gases, to the solid form, basically, sorry, when you put on the higher temperature to the solid particles, you just broke up their attractive forces. You just reduced their attractive forces. Now the attractive forces were reduced, the spaces between their particles were increased. When we go through this decrease and increase, what it caused, it made particles to got melted off so that they were converted into the liquid state. That particular point was called as melting point. Further, we reversed this activity and we said no, we want to make a reverse activity. We convert it into the sol. We want to make a shift from liquid to the gaseous state, reverting all the activities. In that case, we have to decrease the temperature so that we could make particle to develop some to throw up that energy outward, and reducing that temperature would cause freezing of the liquid into the solid form. Next concept we came to know is that freezing point, we decrease temperature, things got frozen up. Next concept was the boiling. What the boiling point is, some people used to say that it is that point when first bubble appears right at the surface of a liquid is called as boiling point. At that particular point, we are shifting from liquid to the gaseous state. Now, when they are making this shift, we can simply say that we are now decreasing the space between the liquid states, and we are increasing the space between the liquid particles. And when the space is decreased enough, we are jumping from liquid to the gaseous phase. What this transition is, we are actually trying to reduce the attraction between the particles. So the higher the temperature is, the least would be forces of attraction between the particles are, and the least energy they would hold between them. Okay. Now, okay, the next part is going to be the evaporation. What evaporation is? Evaporation is a different process in any liquid or gases. The average speed of the particles vary with the temperature, but at each temperature, some particles will be moving faster than that of the average particles, or other moving slowly. So you can say that whenever it is basically conversion of liquid into vapors, this is called as evaporation. So some very fastly moving particles at the surface of liquid will have enough energy. Now, what's happening there? So you can see that there are lots of particles are present there. Every particle would be needing enough energy to get rid of the they are facing two type of attraction between them. The first one is right there, I mean, like the particles are present at the ground level. Other is like this guy is going to leave this entire attraction. So they should possess an energy to get rid of the attraction which is being applied from this downward area or from the bottom area. So this is if they got succeeded to evaporate, to convert themselves from this liquid to the vapors, this is called as evaporation. The rate of evaporation varies from substance to substance, from liquid to liquid. Now, some very fast particles at the surface of liquid will have enough energy to overcome the forces of attraction between them. They will break away these attractive forces, they will get rid of these attractive forces, and they will immediately convert themselves into the gases. Now, this is called as evaporation. Whenever one convert, whenever the atoms or the liquid get rid of those attractive forces, and they overcome the attractive forces which are being applied right from the bottom of this container, and they succeeded to convert themselves into the gases. This is called as evaporation. If the liquid is in a closed container, the particles in the gas would be colliding with the surface of the liquid. So basically, whenever you close the container or the lid, the particles, and you keep on heating them from the bottom, just providing them with artificial heat. Now they are going to make a force onto them, and they will be keep on colliding with each other. Whenever this collision occur, they are going to touch up to the surface of that lid. Now right after that, if you are keeping that lid closer, obviously they cannot go out of that particular bottle or any container. But if they are still, if they are moving slowly enough, they will be held together by the forces of protection and all that. Now, in a closed container, they cannot be evaporated. But if you open up the same container, the particles will obviously leave the container. They will be leaving the container. That is called as evaporation. So, simply in a closed container, evaporation and condensation both will occur at the same time. Now, what the condensation is? Condensation is when a liquid is converted, when gases are converted into liquid. This is called as condensation. Evaporation is when a liquid is converted into the gases. Obviously, when you close a container, there is no space for the liquid to go out. It will be converted into the gases, and from gases to liquid immediately. Why? The reason being is that you have just closed the container. They have no space to leave it. So they have to stay inside that particular container. Okay. So